My DX-160, have I managed to kill it permanently?
Ladies and gentlemen, I present to you the junk pile. Now, there's no point in having a junk pile like this if you're not going to avail yourself of the treasures that await you. I need a transistor. I'm waiting for it to come on a very slow boat from China. So rather than wait, you know me, I like to put things in and see if smoke comes out. So I'm going to pull that transistor, that pass transistor, out of the DX160, and I'm going to pull a transistor out of this supply, see if I can find a PNP transistor that kind of looks like it might behave the same way. I'll look at the HFEs and everything else. It's certainly not going to be the recommended transistor, but I will pop it in and quickly check the voltage to see whether it's where it should be. Once again, it might not be behaving as it should. Not the smartest thing to do. But I just don't like to wait. Very impatient. In this supply for a computer, there is a number of transistors that could be likely contenders. They may be FETs. I actually don't know. But I'm going to have a look, and hopefully they've got part numbers on them. We can have a look at what the characteristics are like and make a decision as to whether we're going to attempt to use one of these transistors in our device. It also gives me opportunity to desolder the one that I think is dead and pop it in the transistor tester and just double check that that is actually the case. Worst case scenario, this doesn't work, and hopefully we don't blow the radio up, and then I'll just have to wait for the part to arrive. But if it's working and it seems to be okay, hey, what the heck? Get this PCB out. I tend to hold on to screws when I take them out, and more often than not, they get used somewhere else. Nothing worse than trying to find a screw that you need and not being able to get it, and then realizing that you could have kept the ones you threw away. And I haven't shorted out these capacitors yet, so that's probably something I should do too, because they could still be carrying a massive voltage on them, which would be an unpleasant thing to come across. Although they usually have bleeders on them. No, that's long discharged. So we'll look at some of these transistors that are on this heat sink and on this other heat sink. These ones that are in here actually look like they might be a better contender, and we'll see how we go. Fingers crossed. We've got the board out. Okay, turbines to speed. Let's get this desolderer going. This is one I got from the electric markets in Bangkok. I've only used it a couple of times, but thus far it's been pretty good. There we go. There it is. As we can see here, component testing of that component is indicating that it's a diode. That's a good start. Let's hunt for some transistors. See if we find one that will at least start the thing up. And obviously, if the proper transistor arrives, I may replace it. But if I've got the same voltage and it's behaving itself, why would I bother? We've got another nondescript semiconductor device out. Let's see what the component tester says. I've reeked out of here. I think the last thing I got was some sort of voltage regulation device. These are coming up as resistors. Let's have a look and see if it tests another transistor that we know is... There we go. That's an NPN transistor. In fact, I didn't even know I had this. What is it? It says it's an LM7809. Lord only knows why it's reading a 3-pin regulator as a transistor, but maybe they are transistor-like. Well, anyone that knows anything about switch mode power supplies is probably shaking their head at the moment and going, how is he going to find a bipolar junction transistor in there? So we've dug a couple out and nothing's happened. We also had a blockage in the desolderer. you have to learn the tips and tricks of how to use all that equipment too. But once I've gotten the desolderer going, I've got to say, like, I'm getting components out of boards like that so quick and so easy. What I've done is I have managed to remove a transistor that's probably an audio transistor, being as it's come out of this car stereo amplifier. And the transistor that's actually doing the, I guess it's like a voltage regulation series pass transistor in the circuit for the power supply in the DX-160 is actually listed as a 5-watt audio amplifier. I am thinking that this transistor is probably quite a bit more than 5 watts. And when I hit test on it, it is coming up as a bipolar junction transistor with an HFE of 133. So what I might do is have a look at how that compares and contrasts to the parameters for the other transistor. Yeah, maybe just put it in and see what happens, just for fun. So the plan is to pop this very much larger transistor in. I'm going to heat sink it on this, and we'll see how warm it gets, how much current it draws, and what voltage we end up with on the other side. It's supposed to be around 9 volts, so I will have it hooked up to a voltmeter, and if it looks like it's going to fry things, I'll switch it off quickly, although if it goes too high, I'm probably going to blow something. I'd love to have a variable power supply that I could slowly ramp up. I don't have that. I could play around with a voltage dropping via resistors, but can't be bothered. Let's put a little dab of heatsink compound on here. Let's see how little dab will do you. And we'll get it mounted on that heatsink and then put some leads on it. We'll make them long so we can clip a voltmeter on. And fingers crossed it doesn't fry my radio. Okay, folks, do we want the good news or the bad news? Well, the bad news is that all this jiggery-pokery with this transistor was a complete waste of time. It doesn't have the characteristics necessary to get it to switch on. Look, it was a stab in the dark. What I was really worried about was once I got this in, that for a moment there I thought it was working and that we had no audio, which would have been terrible. So what I've done, after looking at the pinout and back at the schematic, I realized that there was still no 9 volts coming out of this circuit here. So we have put ourselves a 3-pin regulator here. This is an LM 7509, I think it is. Anyway, 3-pin regulator that provides 9 volts DC. But I just wanted to put 9 volts at the output of that transistor, which is roughly what we require there for this circuit to work, to see if we have any audio. So I went and I got our speaker that we've been using with this wonderful receiver, and I was just very, very worried that I had fried that audio chip. I went online and looked for this particular audio chip. It's a UPC 20C NEC chip. It's about 1 watt audio. It is scarce to find, and people are asking $20-30 for them. And I just thought, so, you know, had that died, I'd probably be doing a radical Frankenstein monster rebuild on this and really pissing people off. But watch what happens now. When I switch on my 12 volts, as you can hear, we have audio. Medics who was killed. Well, while we're waiting for that transistor to arrive, I have installed that voltage regulator, and let's just see if it works. Yippee-ki-yay!
Just before you roll over, Peter, what microphone do you have with it? Do you have the MX31 series microphone or something different, Peter? What was the microphone with it, Peter? It sounds fine. I'm not picking on it. I just wondered what the mic was.
Okay, it's been a wonderful Sunday. As you can see, the DX160 is back online. I am waiting for the official part to arrive, and I most likely will put that in just for the sake of having the part that's supposed to be in there actually in there, but seems to be working all right with the 3-pin 9-volt regulator. What I'm going to do now is I have modified the one tube transmitter, which is over on the test bench, and I'm going to set it up so that the standby switching works, and I've fixed that problem that caused the initial failure of the power supply in this now, so it shouldn't happen again. And I just want to set it all up and see if it's still operational. And also, the shack is a complete and utter mess. It's getting to that point where I have a certain mess threshold, after which point in time I start to become a little bit... So we will be cleaning up, but not tonight. Tonight we're just going to get this set up. This is the Kiwi SDR VK5 ARG in South Australia. It's over 1,000 kilometers away. It looks like I'm only putting out about probably not even a watt, but take a look at this. This is the miracle of Morse code. And here's the setup: digital VFO, care of QRP Labs, and all the add-ons to get it to work with my single tube transmitter, which now has a way of isolating the side tone. So it's in transmit at the moment. If I flick it over here, you can hear the side tone. If I don't want that side tone to be making a lot of noise, we can avoid the noise. Well, folks, I am completely chuffed. Don't we all love a happy ending? DX-160 is working again, and we managed to land a QRP QSO using the magic of Morse. 2 watts all the way to Melbourne. We could hear it also in South Australia. And what was really great about this QSO with Peter, VK3 EPW, so thank you, Peter, for answering the call, was that Peter's rig is also homebrew. So it was homebrew to homebrew using the magic of Morse. Thank you for sticking around right to the end of the video, and I shall see you in the next episode of The Art of Engineering 7.3.